Okay, in this problem, we're asked to find the directrix, and we're given the equation of a parabola. So um, we know that since this has got an x squared in it, right, that this is going to be a vertical axis of symmetry, and our parabola is going to either open up or down. And so part of what we have to do is just kind of go through and figure out what that's going to be. Um, I'd like to put it in this format right here. In this format right here, right? Because in order to find the directrix, I need to find f. So I need that focal length. I need the vertex and I need the focal length. And then from that, I can figure out the equation of the directrix. So I'm going to try to rearrange this equation to make it look like this. I'm going to get the x squared by itself on one side, and I'm going to make sure I can put it into this perfect square format. And then the other side with the y, I just want to arrange it so that I've got a number out in front here, and then times y minus k. So so here's how we'll go through this. So I've got y is equal to 1/2 x squared plus 6x plus 23. So the first thing I'm going to do is I'm going to get rid of this 23 over here. I'm going to move it to the other side. So so I'm just going to subtract 23 from both sides. So I've got y minus 23 is equal to 1/2 x squared plus 6x. Okay, and then I'd like to get rid of this half here too, because completing the square here, right, it'd be much easier if I didn't have that half. So I'm going to multiply everything by 2. I'm going to multiply both sides of this equation by 2. And so I'm going to end up with 2y minus 46 is equal to, that'll make that half go away, so that'll be x squared, and then 2 times 6 is going to be 12, so 12x. Okay, so getting closer here, I just want to complete the square here, right? So I want to add some number that'll turn this into a perfect square polynomial. So I'm going to take half of this number here, which is 12, and half of that's going to be 6, and I'm going to square that. That's going to give me 36. Now, since I've added 36 to the right-hand side, I'm also going to add 36 to the left-hand side as well. So now if I got 2y, that's going to be minus 10 is going to equal, and then if I rewrite that in factored form, this is going to be x plus 6 squared. Okay, so we're getting close. Now, I've got the right-hand side, right, the x squared part, how I want it. I just want to change this part here, right, to make it some number out in front times y. So I'm going to factor 2 out of here. So I'm going to take a 2 out of here. This is going to be y minus 5 is equal to x plus 6 squared. So a couple things I can tell from this. First of all, I know that my vertex is at, what's that going to be? It's going to be negative 6, 5. Negative 6, 5 is going to be my vertex. Okay? I know that this value right here, 2, that's my 4f right here. So I know that 4f, let's say I know that 4f is going to equal 2, which means that I know that f is going to be, divide both sides by 4, I'm going to get 2 over 4, which is going to be 1/2. Right? So my focal length is 1/2. I can also tell that because this 4f number here is positive, that means my parabola opens upward. Okay, so it's going to open up like this. So my vertex is going to be at negative 6, 5, and my directrix is going to be below that. So it's going to be half a unit below that. So my y value here is 5, so my directrix is going to be half a unit below that, so my directrix is going to be where y is equal to 4.5, half a unit below that. Okay, and we could go through here and find out, all the rest of this as well. We could find the focal point and some other values, but that's generally how we do that. We're going to take that process of of completing the square, right, that we did when we were finding circles, and apply that to parabolas.